Welcome to qnawire.
We have this cube here which is pushed with a force at the point C, and we need to find the time that it takes for this cube to complete one full revolution, knowing that it can rotate about this diagonal from point A to point B. And we know that the mass, so the mass m prime, this is the mass of one side of this cube, which we can get by taking the total mass and dividing it by 6. And the mass of one side of the cube is given as 8 kilograms. So 8 kilograms. And when we're solving this problem, we're going to assume that the x, y, and z axis are all perpendicular to the faces of this cube. So we're going to start by finding what the moment of inertia is for a side that's perpendicular to the x-axis. So we'll call that I of x1. So I of x1. And we can write that as 1 over 6 times m prime times a squared. And next we'll write the moment of inertia for a side that's perpendicular to the y or z axis with respect to the x-axis. So we'll call that I of x2, and that's going to be equal to 1 over 12 plus 1 over 4 times m prime times a squared. And we can simplify this as 1 over 3 times m prime times a squared. So now to get the moment of inertia about the x-axis, we can take these two terms here and take the summation of them. So to write that, I of x, we're going to write that as 2 times I of x1, since there are two sides that are perpendicular to the x-axis, and then plus 4 times I of x2, since there's 4 sides that are perpendicular to either the y or z axis. So now we can just plug in those values, and we're going to write that as 1 over 6 times m over 6 times a squared plus 4 times 1 over 3 times m over 6 times a squared. And we can simplify this to 5 over 18 times m times a squared. And since this cube is symmetrical, we can say that this is also equal to the moment of inertia about the y direction and also the z direction. So now we're going to write the equation that can help solve for the moment of inertia about the vertical axis. So I'll write that. So we're going to write that out. So we can say that the square root of 2 over 3 times a times the impulse is equal to the moment of inertia about the vertical axis, which I'll call I of v, times the angular velocity. And we're interested in the angular velocity. So what we're going to do first is we're going to replace this term here, this expression here, and plug it in for I of v. So we're going to rewrite this. And then plugging in I of v. And then we take this and we solve it for the angular velocity. So now we can plug in values for these unknown terms, or for these known terms rather, and then solve for our angular velocity. So we plug in A, then we plug in the impulse, we plug in the mass, and then plug in A. And this will give us an angular velocity that's equal to 2.4495 radians per second. So now the time it takes to complete one full revolution is going to be equal to 2 pi divided by the angular velocity. So this time is equal to 2 pi divided by our calculated value of the angular velocity. And this will give us a time of 2.57 seconds.